of practical field design and project management experience. He's licensed as a structural engineer in Illinois and as a professional engineer in Illinois, Wisconsin, Iowa, and Missouri. He's a graduate of the University of Illinois Urbana-Champaign with both a bachelor's and a master's degree in civil engineering. His co-presenter is Rick Manor, who has both a BS and an MS from the University of Illinois Urbana-Champaign. He started his wastewater career at the Elgin Sanitary District's pre-treatment coordinator. And in 2011, he joined the Urbana-Champaign Sanitary District staff as the executive director. So please welcome Matthew and Richard.
Thanks, and definitely thanks for sticking around. We really appreciate it, and appreciate your interest in our little pump station project. In contrast with the earlier two talks, rather than doing any views of the landscape, I couldn't decide in central Illinois whether to put up a picture of a beanstalk or a cornstalk, and so I decided to go with neither. That's your choice on our landscape. For this project, we, although it's Fehr Graham and UCSD here giving the talk, in reality, you can't do any type of project of infrastructure through an urban corridor without a lot of cooperation. And we had that from all our partners, including the city of Champaign, which gave us a great site for where to build this. The Champaign Park District were right next to an urban park, and they were deeply involved in regards to the aesthetics as to what we put in, and we really appreciated their help as well. The University of Illinois gave us a decent route for where we put the force main, and in particular the gravity sewer portion of this work. Matt will probably touch on a few of the interesting aspects of dealing with the university, and I'll just leave it at that. But doing construction on campus is its own story. Why we needed to put in this Second Street pump station. The University of Illinois has a typical Big Ten school, 40,000 individuals there. And what has happened over the last several years coming out of the recession in terms of building, we started to see 1, 2, 3, and then a dozen tall buildings popping up on campus. And these are private dormitories, 300 to 600 PE each, and popping up all over the place. And so we were actually seeing a transition. If you would picture one of the suburbs around your area of 40,000 people suddenly having 4 tower cranes working at the same time. And that's what we had in 2014 in terms of a radical shift from relatively sleepy building out on the edge of town to suddenly deciding that the heart of campus was where everybody wanted to build at the same time. And so we saw that transition, and as you'll see in a second on the sewers, in terms of the challenges we're faced with, it's all driven by this money towards building high-end residential development in what we call campus town, as opposed to a downtown area. It's where campus is. So here's an aerial view of our service area, Champaign and Urbana in central Illinois. And here's the sewer system as it was built up. Over here in the east is our northeast plant. That's the original plant built in the 1920s. Over here in the southwest is our southwest plant built around 1970. And so this dense area here where you see 3 or 4 interceptors is the joining of downtown Champaign, campus town area, and downtown Urbana. So that's the original district, is this area here that I'm circling with the mouse. And in that area, we have what we term the 56, the 46, the 1923, and the 98. And that's the age of those sewers, built in 1956, 1946, 1923, and 1898. And so when they designed those sewers, they did a great job looking forward 50 years, but they weren't really picturing the idea of 20-story buildings dotting every major intersection along the area. And so they did a good job on giving us good size that's worked for upwards of 100 years. But we were faced with how to deal with all of this new flow coming up in a variety of spaces in this area. And we don't have control over which interceptor they were going to build upon. So we had to try figuring out how to do this, and putting in a fourth interceptor through that area would be an even worse construction site. And so instead we came up with our Second Street pump station. So before we even started this project, we already had a few sanitary sewer overflows, especially during extreme storm events on this line here, the 1956. And then these asterisks are just a dotting of the several hundred PE buildings that have been popping up. There are a couple out on the edge, but for the most part, they are all concentrated here in this campus area. So this is the sewer system. The green is our southwest plant, and you can see it's the smaller part of things. All the multicolored sewers over here are our northeast plant. And this is the before Second Street pump station existed. This is the blue half here is the older sewers, and then the red up here is the 1956 interceptor. And so you can see that we had two problems simultaneously. The sanitary sewer overflows were on the 1956, and the majority of the new construction here was in the 1923, 1898 area. So this is what Second Street did for us. If you notice the transition in colors here, these areas here transitioned from being blue and red to being purple and brown. And that is the two basins that were split off. That Second Street pump station allows us to pump from either of those basins. The north half, being the brown half, was transferred from always going to the northeast plant to being able to go to northeast or to southwest. And then similarly, this purple area down here is the south service area going into our Second Street pump station, and it now can go either to the northeast plant where it goes currently by gravity, or being pumped over to the southwest plant. And what we noticed is we had 3 of those interceptors all within a block of each other. And by being able to choose on which of those interceptors we draw from into our wet well is the key to give us the flexibility to choose what we can do. And by draining those interceptors before they reach the tall buildings is what gives us the flexibility on addressing where the tall buildings choose to discharge into, and to make sure that there's enough room in those sewers for those flows. And then with this, I'll turn it over to Matt Johnson, who's going to cover the details of the design.
Thank you, Rick. This project certainly had its fair share of challenges, although as we got started working on it, I found one of the largest challenges was trying to figure out what the sanitary district meant by a 98 sewer. Is that how big it is? You guys don't have 98-inch sewers, do you? But of course they were referring to the 1898. So several challenges that were faced with this project, mostly related to the location of the pump station at 2nd Street was dictated by the location of the existing interceptor sewers. As Rick was just mentioning, there was a very convenient space for that pump station where 3 interceptors were coming together within a block of each other. And so a very natural location for a diversion pump station. The unfortunate thing is that just also happened to be where the Champaign Park District just invested over $5 million in an improvement to a park. Not to mention the fact that several developers were working on high-rise apartment buildings that were supporting that campus development. So as you can all imagine, when the sanitary district and their lowly engineers approached the Park District and the city with the idea of putting a sanitary pump station right next to all of that new infrastructure and new investment, we didn't exactly get the best reception. So they were kind enough to listen and not just simply kick us out of the room. And I would say the result certainly was one of the only pump stations that I have been involved in that actually had an architectural committee assigned to it. So in addition, because it was on campus, there was a requirement from the University of Illinois that all construction be while the students were not in session. So we have all of these design elements that we're going to talk about here in a little bit. And oh, by the way, you can only be on campus with any of your equipment or contractors between May and August. So go figure it out. Good luck. We were able to figure it out. What we did was come up with a two-phase approach where the majority of the pipeline that would be running through Campustown would be completed under phase 1. Phase 2 then would be completed with the 2 pump stations that we're going to talk a little bit more about, along with some gravity interceptor sewers that were on the south end of the project. The result was a project that, if any of you have participated in a project that was planned as one particular project that started and finished in a very orderly and regular fashion, and then that gets carved up into several phases with different timing requirements. Generally speaking, you expect that to go long and to go over budget. But with the great coordination between all of the various people involved in the project, we were able to deliver the project on time and on budget, and it was a challenge. This is what I would refer to as the keystone of this project. This is the pump station at 2nd Street. What you see coming in from this side, the north is on the right over here, the south is on the left. This is 2nd Street. A 27-inch interceptor extends from a wet well in the street to the old, I believe it's a 27-inch interceptor, and then a 12 and an 18-inch interceptor are down here on the other blocks. We ended up with a split wet well design, which allowed us to then isolate those interceptors on either the north or the south. So with Rick's graphic, you saw that he's had a north contributory area and a south contributory area. During the planning phase, this was going to be one pump station and one well, but we did split it to allow for that isolation. We also added a valved pipeline, interconnecting pipeline, that could be opened, and that this pump station then would function as one single wet well. When that valve is closed, the level in this wet well can be different than that wet well and can be independently then controlled based on how the sanitary district wants to deliver water to either its northeast or its southwest plant. It was a concept that was very well received by the sanitary district. We do have level monitoring devices that are located in each wet well that allows the through SCADA system, the operators at either southwest or northeast to see exactly what the levels are in each of those wells. There is a program that is run that will allow for the level in each of those to be selected, and then the pumps will ramp up and down as necessary in order to achieve that level. So it is real time, and they can optimize to adapt to the situation that they are faced with. I would also say an interesting element to a pump station project is there was an element of this project that addresses nutrients. As Rick was mentioning, one of the district's plants on the northeast is an older facility and does not include any provisions for nutrient removal in its treatment train. The other plant at the southwest does have an A2O biological nutrient removal process, meaning that if we do need to, and they actually go into 2 different watersheds as well. So if we want to remove a phosphorus load or a nitrogen load from one watershed, for whatever the reason may be, the district can intelligently select and move that water over from one watershed to the other, and then get the removal from its more advanced treatment train at the Southwest Treatment Plant. I mentioned the architectural committee already. This is a picture of the $5 million Park District project through, I believe this is the Boneyard Creek here. And here are some pump station, some pictures of the pump station and how we were able to match the stonework and the architectural elements of the park with the sanitary pump station. I remember one of the first meetings that we had with the city was we'd really like to have something similar to the well houses in downtown Chicago. Okay, well, we'll see what we can do. This is an aerial photo with some lines drawn on it to help illustrate exactly what we were doing here. There are 3 interceptors, 1 on the north, 2 on the south. This picture's actually got the south on the top of the page. So the existing interceptors, we have a pump station with an up to a little over 5 MGD capacity. The discharge of the pump station, when it is wanting to divert flow from the northeast to the southwest, will engage a 20-inch force main that delivers flow down to a gravity sewer that was newly installed as part of this project. The benefit, once it gets to through gravity, then it will go to another pump station that's referred to as the South First Street Pump Station, and from there it goes on to the Southwest Wastewater Treatment Plant. The South First Street Pump Station, since it is now able to receive an additional over 5 MGD worth of flow, also needed to be upgraded, and we're going to talk briefly about that. Because the pipeline, it was a 20-inch pipeline, had to be routed through campus and it had to be routed quickly, a majority of it was installed with directional bore methods. So a couple of pictures of actually stringing a pipe right down the middle of a residential street, and we happened to be able to do that because nobody was home. Campus was pretty well shut down at this point. A couple of cool pictures of the ream. The boring contractor did a very nice job with protection of utilities, particularly when most of the time the Julie utility locates were as good as they could be, but frankly the university did not know everything that they had in their right-of-way. In fact, we got to a point in the project where we had 2 full GIS crews from the university following us so that they could take shots on their own right-of-way and know what they had. I find it comical, but I'm glad we could help. This is the new gravity interceptor sewer. It is gravity at this point because we were able to, for a couple of reasons. One, for future expansion. The University of Illinois Research Park is planned to be installed in this area, and this is some of the first phases that have already been developed. The pieces that have been developed obviously had a drain that was going to the South First Street pump station before our project, and then as we put this new gravity interceptor in, the future flow that as the University Research Park develops will go to it. You notice a branch going off to the east here. This is a branch that will pick up an existing pump station. It's the Orchard Downs pump station, services student housing, and was, before this project, responsible for about 300,000 kilowatt hours per year on the grid. Because we now had a gravity outfall, we were able to decommission that pump station, get that operations and maintenance costs off of the university. So it was mutually beneficial. We're going to see in a little bit how it can also benefit the sanitary district. Down here at the South First Street pump station, for those of you that are the big machine type people, this is a Tim the Tool Man kind of pump. This is a 425 horsepower diesel powered pump. We went with diesel rather than electrical power because of where this was. The 1200 amps that we were going to be required to have on site in order to run the electrical pumps, the additional electrical pumping was going to cost about another $500,000 to $600,000. With the diesel pump then, we were able to remove that ongoing operations and maintenance costs in exchange for diesel fuel. The diesel pump really only needs to run about 4 to 5 times a year when that real peak heavy wet weather flow does hit. It did get installed in a dry pit, as you notice here, in order to avoid the derating that was going to happen with the large suction lift. I believe without that pit, we were going to have a 25-foot suction lift and lose about 1 MGD of capacity. With that pit, we got the full 7.5 MGD capacity that we needed.